Welcome to This Explainer. Today, we are pulling back the curtain on a concept that, honestly, quietly runs our entire digital world: data integrity. We're going to break down what it is, why just one tiny error can cause total chaos, and, of course, how we protect against it.
Okay, let's dive right in with a simple but really powerful idea. Imagine this. You order a brand new phone online, you're super excited, but because of a single data error somewhere, a toaster shows up at your door. Yeah, a toaster. That's a data integrity failure in the real world. It's all about making sure the information is right, from the second you click buy all the way to your front door. So here's our game plan. We'll start with the big picture definition, then break it down into 4 key types. After that, we'll look at the tools we use to protect it, see it all in action with a real-world example, and then we'll wrap it up with a quick recap of the main points.
All right, first up, what are we actually talking about when we say data integrity? Let's get right to the heart of it. You know, at its core, data integrity is really a promise. It's the promise that your data is accurate, meaning it's just plain correct, that it's consistent, so it's the same no matter where you look, and that it's reliable, which means you can actually count on it, from the moment it's created all the way through its life to the moment it's put away in an archive.
And believe me, this promise is critical. Without it, big business decisions are basically just guesswork. Costly mistakes like sending a toaster instead of a phone, they become way too common, and pretty much everything just slows way down. Think of data integrity as the engine of a smooth, efficient operation. If that engine fails, the whole machine just grinds to a halt. Okay, so let's build on that idea. Data integrity isn't just one big concept. It's really held up by 4 distinct pillars, and understanding these is the key to seeing exactly where things can go wrong.
Now, this is where it gets really interesting, so let's slow down just a bit. First, we've got physical integrity. This is the most straightforward one. It's all about protecting the actual hardware, from stuff like power outages or floods. But then we get into the data itself. Logical integrity is about making sure the data follows the rules. For example, a system might have a rule that says an email address has to have an @ symbol. Simple, right? Next up is entity integrity. This is kind of like giving every single person in a huge phone book a unique ID number. No 2 people can have the same one, so you always know you're looking at the right John Smith. And finally, there's referential integrity. This makes sure that relationships between data actually make sense. You can't assign an order to a customer who doesn't exist in your system. It keeps all your data from having these broken links that just point to, well, nothing.
So we have our 4 pillars, but how do we actually keep them standing strong? Well, that's where the professional toolkit comes into play. This slide lays out 5 key practices, and the analogies are just perfect. Think of data validation like a bouncer at a club, checking every piece of data as it tries to get in to make sure it's valid. Auditing is your detective, constantly checking for errors or things that just don't add up. Access controls, which you'll often hear called RBAC, make sure only the right people can make changes. The finance team gets to edit the budget, not everybody else. Version control is basically a superpowered undo button for your data, letting you track every single change. And of course, data backups. Well, that's your ultimate safety net for when a real disaster strikes. Okay, so we've seen the pillars and we've seen the tools. Now, let's put it all together and see how they work in harmony to build a solid blueprint for protecting data. And this just illustrates the relationships perfectly. Take a look at how a single practice can support multiple pillars at once. For instance, good old data backups are obviously crucial for physical integrity, if a hard drive just dies. But think about it. They also restore logical, entity, and referential integrity by rolling the entire system back to a clean, consistent state where all the rules and links were still perfectly intact. It's like a system of overlapping defenses. Let's make this all super concrete with a quick case study. Picture a massive, global logistics company, the kind that moves thousands and thousands of packages across the planet every single day. For a company like that, data integrity isn't just theory, it is absolutely everything. So in this kind of high-stakes world, they use very specific tools. They absolutely use role-based access control so that only an authorized coordinator can update a shipment status from in transit to delivered. They run constant audits to catch discrepancies, but here's a really cool one. They use checksums. Okay, think of a checksum like this. You count the number of words in a sentence before you text it to a friend. When your friend gets it, they count the words too. If the numbers match, you know the message arrived intact. Checksums are just a digital and way more sophisticated version of that, making sure data doesn't get messed up during transfer. And this is the crucial point. The risk of failure is just enormous. One wrong number in a shipment record isn't a small typo. It could literally mean a container of critical medical supplies ends up on the wrong continent. That leads to huge financial losses and, just as importantly, a total loss of trust from their customers. The takeaway here is crystal clear. For this company, and really for any modern business, strong data integrity isn't just some concern for the IT department. Nope, it is a core business function, and it's absolutely essential for keeping the lights on, operations running smoothly, and customers happy.
All right, we have covered a ton of ground, so let's do a quick flyby of the most important points just to lock them in.
If you remember anything, remember these 4 things. 1. Data integrity is all about data being accurate, consistent, and reliable. 2. It's held up by those 4 pillars: physical, logical, entity, and referential. 3. We protect it using key practices like validation, auditing, access controls, and backups. And 4. At the end of the day, the goal is simple: prevent errors and make trustworthy decisions.
And because I know those 4 types can be a little tricky to keep straight, here is a handy little memory tip. Just think entity for unique records, referential for linked tables, logical for the rules and constraints, and physical for protecting the actual hardware. And I'll leave you with this final thought. We started with a mistaken delivery, right? Now I want you to think about your own life, your bank balance, your school transcript, your medical records. Now you know the principles that are working behind the scenes to protect them. So where could just one small data error cause the biggest problem for you? Something to think about. Thanks for watching.